To this lesson. So in this lesson, we want to look at orchestration for agentic system. How does agent implement as workflow? How do they solve tasks, or systematically and strategically? So how agents sequence action, route decision, recover from failure. It's what we call orchestration system. Okay, so how does it route action? How does agent communicate with each other? How do they communicate with the database, with the tools that they want to call? So how agents sequence action, route decision, recover from failure, and scale safely is our discussion here. If this is your first time in this channel, just remember to like and subscribe to help us. God bless you. So orchestrator, state, plan, and supervise. So orchestrator is like the brain of the, it's like, a director or CEO of a company that oversees all the operation, all the managing directors, or the general managers, the managers, and every activity and workflow of the company. So orchestrator is just like the CEO of an agentic system that allows, that oversees all the activity happening in the system. So we have control flow, route sequence cover, tools, API file and DB, agent, roles, worker, and outcome, coherent end-to-end task. So this is just like the architecture design of an orchestrator. So it is connected to the control flow, which routes, sequence, and recover. Then from control flow, it can call a tool and assign a tool to an agent. It can call an agent, it can call a tool, and then it uses tools and agents to generate outcome. So it basically link agents to a particular tool or chooses an agent to solve a particular problem. So what orchestration does, it turns isolated skills into coherent end-to-end agent behavior. So orchestrator turns skills to agentic behavior by assigning skills to a particular agent and, assigning agents to a particular tool or taking, action from agents and passing it to another agent. That is what orchestration does. It's, uh, allow the agentic workflow to run smoothly without interrupting each other. Then look at this design pattern. Current state, that is context, goals, and constraints. That is, we have a context, a problem to solve, which is the current state. Then choose next step, that is action or two. So this is what you have at the initial state of the orchestrator. Then next step, it chooses action or two based on the context that is passed onto it, and then it is then routed to sequence and supervise, execute with control all the activity, adapt plan, new info, changes paths. So it adapts and plan what to do next without orchestration. Tools conflict, tools conflict, workflow stall, system become brittle. So if there is no orchestrator, there will not be sequence, there will not be pattern of solving problem, there will not be planning or reasoning in the system architecture. So orchestrator allow the agent to choose the right tool. It allows it to follow, a sequence and structured workflow, and it make the system, to be responsive. So recover and reroute. That is, orchestrator also has the ability to retry, to fall back, or to escalate when something goes wrong. So choose which action or two to take next from the current state. That is the ability of the orchestrator. It can choose which action or two to implement. It supervised execution while adapting as new information arrives. It also handles failure through retries, rerouting, and recovery paths. So it handles failure in the system. So common orchestration patterns. So reusable control flow templates help teams design predictable agent behavior. So you can see this design pattern. At the center in blue, we have the orchestration pattern library, so which allow the agent to pick the smallest pattern that solves the control problem. Then design pattern, the first one is reasoning and acting, which is known as react. So reasoning step plus loop calls is implemented into the design system. One of the design pattern, we have plan and execute. That is, it allows the agent to plan first before executing step by step. This design pattern allow the agent to list all the plan, to look at the problem, list all the plan to solve it from beginning to the end, and start implementing the plan or one after the other from the first one. Then we have routing pattern, classify input, dispatch to specialist. So this particular design pattern allow orchestrator to route, to pick or identify a problem, assign a tool, and then route the problem, the context, and the tool to a specialist agent that will carry out the action. And then reflection. So it's still when the agent carries out the action, solve the problems, the solution still come to the orchestrator. So then orchestrator reflect on the solution and critique or validate the output and revise it before generally, serving it as response to the user. So it also has hierarchical design pattern. So supervisor delegate to workers. So just like in an industry where you have the CEO, the managing director, you have the general manager, the managers, then you have the workers, the analysts, the advisors, CTO, down to the most junior person in the company. So you also have hierarchical agents. So I'll be writing a book version on hierarchical agent. So please do well to read it and know how to design hierarchical agent. So orchestrate hierarchical design pattern is part of the design pattern that you can implement into your orchestration pattern. So control versus flexibility. The design choice is where decision making should live, code, model, and or both. So when you are designing your orchestrator, make sure you put whether you want the orchestrator to have full control of the system, or you want it to be flexible. So code driven, deterministic, auditable, and predictable. So if the orchestrator is code driven, then you want it to be deterministic, auditable, and predictable. You can also design an hybrid orchestrator, which will route to agents and to workflow. Remember, an hybrid architecture is where you have both autonomous design and a workflow design. So code for structure, model for choices, most common in production. Then you have model-driven design. So flexible, novel parts added to debug. So make sure you also put this design pattern into consideration. Choose your design and work on it. So more autonomy equals to more test, monitoring, and guardrails. So if you are giving the orchestrator more autonomy, make sure you test, make sure you monitor the, the work, the input and the output, and make sure you work with a policy, design policy for the agent by implementing guardrails. Then we have a start constraint. Okay, start constraint, then relax control as evidence and metrics accumulate. So start, as we said, start small and relax the control as evidence and metric accumulate. So when you are sure that the orchestrator agent is behaving well and can handle route work successfully within the tools and the agents, then you can now start, expanding the capability of the orchestrator. So use code for boundaries, approvals, loop limit, and compliance control. Use the model where ambiguity, reasoning, and dynamic choice matter. So framework for orchestrator. So we have this different framework that you can use out there, and the framework provides state, coordination and routing and integration building block. So one of them is land graph, which is very popular among all of them. It is open source, explicit state matchings, inspectable transitions. You have AutoGen, which is multi-agent coordination conversation pattern. So you can design using Autogen framework. You can use LangGraph, you can use Autogen. You can also use Crow AI, which is role-based team, fast prototyping. You can also use Open AI Agent SDK, so which are integrated tools, manage agent primitives. There are many more out there. We have N8N, which is a platform you can also use. Then we have direct API layer. So many teams build directly on API once requirements stabilize. So like I have used LangGraph, I have used direct API layer, I have used Autogen, even OpenSDK. So you can try them out to see the one that best fits your architecture design. So choose framework for speed, state management, and coordination support. Avoid framework lock-in when core orchestration requirements are clear. So do not lock in, just limit your use into one framework. Make sure you design for flexibility and you design your agents to be able to switch between framework. Production concerns. At scale, orchestration must survive long tasks, parallelism, cost pressure, and risk. So your orchestration must be resilient. That's what we are trying to say here. It must be able to recover when there is a problem. So you must integrate that into the design and into your code. So we have first one, task queue, async request. So make sure you implement async design pattern in your code. Checkpoint state, allow the agent to survive restarts. Parallel branches, make sure you implement parallel branches, which allow the agent to control conflicts in the system. Then also implement loop budgeting, so bound token costs, so that you will not be running unnecessary costs. Then also implement decision log, trace every choice, every action, every step of the orchestration. Make sure it is logged. Then human review, always make sure you implement human review for high risk task. Make sure there is human in the loop before the agent can take the final decision. And then also implement fallback mechanism to allow the agent to recover safely when there is a disaster. So stable outcome, reliable delivery. So make sure there is a stable outcome. Make sure your orchestrator is reliably designed for fast delivery. So key takeaway from this lesson, orchestration is the operating system of agentic application. So orchestration is just like, the director or the managing director that directs all the activities, the workflow of all the agents and the tools in your agentic system design. Thank you for listening. Hope you have learned a lot from this lesson. Kindly like and subscribe. Bye.